So today we're going to talk about classes, but before that, let's go and create a new file. So file, new file, .py, save it as a Python file. Okay, so a class in Python. Before we get into what it is, I'm going to describe a problem that has happened since programming basically began. And that is global access. So in a lot of the programs we've written so far, we've been using a lot of global variables. That's to say, we have variables that exist inside this outside layer of the code. So I might be writing a function or a program here, and there might be a number parameter. We'll just say number underscore 1. And that's 33 or something. And then later on, I can actually access this number anywhere else in my code. So if I say define, we'll just say process, no parameters, and then we'll say number equals number underscore 1. And then we'll go ahead and return number. That we will print process. We'll call it in there. Let's go ahead and clear this out and run it. Say Python classes 1. And it prints out 33. So let's take a look at what just happened here. So we have this global variable declared on line 3. We know it's global because it's on the outside layer of our code. It's not inside of a function, it's not inside of a class, it's just free floating out here in space on the outside level of our code. We have this function here called process, and it's accessing that value. It's storing that into a new variable called number, it's returning that number. So it's taking 33, passing it to this other variable, and that variable is getting returned to be printed. And this is bad. This is bad because in programming, global access has led to fatal bugs, insidious bugs, and has caused a lot of damage throughout history of programming. But I'm going to go through an example I've done in my own programming classes, because typically high school kids, middle schoolers, or younger people in general have all played Minecraft. So I'm going to use a Minecraft example here. So in Minecraft, we have variables like health. Player has health, a chicken has health, villagers have health, zombies. Every creature or mob, if you will, in the game has health. And let's imagine for a moment a version of Minecraft where health is defined globally. So we'll say health equals, I think it's 20 hearts is the amount of health that people have. Okay. So if it's defined globally like this, that means that I as a player have 20 hearts, but so does everything else that has health. So does chickens, so do zombies, so do other players, which is okay at first. But if we have parts of this code that access that health and change it, so let's say that we go smack a chicken that has 20 health with a wooden sword, and that's going to take away some amount of health. Let's say it accesses a function called setHealth, and it changes the health by some amount. So we'll say value, need to put df to define this function. And then we smack a chicken, it triggers this function to set health to a lower value. And so we'll just say set health equal to itself minus the value, where the value is just the damage we dealt. And yeah, that's going to change this health to whatever the result of this is. So the chicken's health goes down, but so does our health, because we defined it globally. That means that everywhere health is used, it's set to the same value. So if you kill the chicken, you also kill yourself and everything else in the game. We don't want that to happen. So we have to encapsulate health inside of a class and then access specific healths. So if we hit a chicken, we want to access that specific chicken's health and reduce it. We can do that with classes. And another thing to keep in mind is when we use classes, that's not to say we hit one chicken and every chicken that's rendered, all their health goes down. We want to be for a specific chicken. And we'll get into that later. But for now, let's just encapsulate this inside of a chicken class. So instead of defining health globally on line 3, we're going to say class chicken. And this chicken's going to have a few different variables associated with it. It's going to have health. And we'll set that equal to 5. I think it has lower health than the player. And then it also has a speed that it can walk at. We'll say the speed is 1. And it has other factors too associated with it, like we'll put a variable here that says is in overworld, which is to say that it can spawn in the overworld. We'll say true. We'll say is in nether. Chickens don't natively spawn in nether, so we'll say false. They will not spawn in the nether. I guess the exception is you have a chicken spawner, but we're just going to ignore that exception for now. And then we'll say is in end false. So chicken has all these values, and this health is independent from the player health. We might have a class for a player. Player has health as well, set equal to 20. Has a speed, we'll set it equal to, I don't know, 1 as well. And then it has other values too, like armor rating, set equal to 0 initially, and et cetera, et cetera, et cetera. There's a lot of other values in Minecraft that a player has associated with it. And so we have taken these variables that might be global otherwise, we've encapsulated them inside of a class. To access these, we're going to put the class name and the dot. So we'll say set player health in this function here. And this function is intended to set the player's health to something else. And so we'll say player.health equals player.health minus the value that was passed in. And now we're setting the player's value, or the player's health. And if we want to do it for a chicken, we're going to do the same thing, but instead of putting player, we'll put chicken. And the key part is, like on line 16 here, we said player.health. For the chicken, we would say chicken.health equals chicken.health minus value. And that will change the chicken's health. It'll reduce it. Okay, so this is where the need for classes comes from, is that problem of global variables and limiting access to information in our code so that we don't have other people come on board and code, or maybe we come in later and we define something later on, or causes bugs where every entity in the game has the same health and you reduce one entity's health and it reduces every entity's health. We probably don't want that. So this will cut down those problems. It will prevent them. All right, but that's not all there is to classes. There's more to classes. So the next part of class, we have this here. We have our data fields. Like on the player here, we have health, speed, and armor rating. Those are data fields, or variables that are inside this player class. But we also have functions that we can associate exclusively with the player. So one of those functions might be, we'll say, define get location. And we'll give the player a location. So we'll say location equals a list, and we'll just say 0, 0 initially. So the player spawns at 0, 0 initially. This get location will return the location. All right. And And we can define other functions too. We can say df, we can say, let's say set armor rating. Okay, so we have a function here that says set armor rating, and let's say it takes in 4 parameters. We'll say head, chest, then we'll say legs and feet. And these are we'll just say that we'll assume that these parameters are the inventory locations of the head, chest, legs, and feet for armor. Because in Minecraft, you have a head slot, chest slot, leg slot, and feet slot for armor. And this will take all those, it'll check what it is it diamond, is it leather, is it iron or whatever, and it will do some math, and then it will return, actually not returning, it will set the rating of the armor. So say armor rating is equal to result, and the result is, I don't know, I'll just set equal to 5 for now. But the results can be calculated from the math that it does to figure out what your armor rating is, depending on what's on your player. Okay, so, and this is exclusively for a player. There's other things in Minecraft that have armor. You could put armor on zombies, you could put it on dogs now, actually. And it'll have its own armor rating calculation. But this is the one for the player, and it has some exclusive math that will be done. This math won't be referenced anywhere else, just here, really. And that's why we're putting it inside the player class, because it's a function that is just for a player. It's not for any other entity in the game. Okay, there's one more missing thing for classes, and that is an initializer function. So an initializer function is declared the same way regardless of what you're doing. So this class could be for Minecraft, it could be for throttle control on the engine, it could be for any application of a class. It's going to be declared the same way every time. So you want to pay attention for this part. So you say def or define, then underscore, underscore, init, underscore, underscore, and then the rest of the function. Okay. So this is an initializer function. It initializes the class when it first is created. And so we have to pass in a few different things here. We have to pass in a health. We have to pass in speed, armor rating. We might pass in a location as well. And now we're going to take a specific instance of a player, which is to say, if you have a map with multiple players on it, we're going to look at a single player when they're being created in the map, when they spawn in. We're going to set their health. So we're going to say self. I'll get into what self means later on. Dot health equals health. Then we're going to do the same thing for speed, armor rating, location. That's how you'll do every initializer function. Say self dot speed equals speed. I misspelled self over there. At the end of this, we're going to say armor rating, self armor rating is equal to armor rating. We're going to say self dot location, no, not legs, location is equal to location. All right, this function here, the special initializer function, it triggers one time, and it triggers when a specific instance of a class is created. So in Minecraft, when a player spawns in, this initializer function will fire off. It'll set all these values here. So let's go ahead and create a player. Let's go ahead and come down here. So let me just get rid of all that. Got rid of our chicken class too. We don't need it right now. So we're on the outside layer of our program. Let's say that we have our main game loop doing something. And let's say that beyond this point here is the main game loop where all the game stuff is happening. We're going to now create a player. You might ask, Well, didn't we just do that up here? This is the definition of a player. We have defined a player, have not created it yet. So we've defined what a player is and what it can do, but now we're going to create one. So we'll say player underscore one is equal to, let's say player. Now we're going to pass in the values that we want the player to have. So for health, we're going to say 20. For speed, we'll say 1. For armor rating, we'll say 0. And for location, we'll spawn them in at 0, 0. Okay, so we created player 1. Now let's say we were playing with a friend and player 2 is going to spawn in, but we don't want player 2 to have as much health as us. Let's say we want player 2 to have less health. So if we were messing with the code, we might say something like player 2 has 10 health, but everything else is the same when they start. So they would have half the amount of Minecraft hearts that we would have. And so if I print player 1's health, so I'll say dot health to access the health, and I'll print player 2's health, save this, jump over here and run it. Hope I didn't have any errors in it. Yep, I got an error. It says, oh, for positional arguments, all right. Got to pass in something else as well. This is the self thing I was talking about earlier. To pass in self in its definition here. I'll explain self in just a minute. For now, just take it as this has to be here for now. I'll get to that in just a minute. Okay, let's try running it again. There it goes. So we have 20 and 10. Those two numbers are printed out. They were printed out because in the main game loop, we defined player 1 to have 20 health here. We define player 2 to have 10 health right here. And then on line 29, we access player 1's health. We pass that to the print function to print out. On line 30, we're accessing player 2's health, and we're printing that out. So 20 is player 1's health. That's the first thing that's printed out. And after that is 10. The second player's health is printed out, just like we saw here. That's how you create an instance of a class. A class is a general definition. This up here is a general definition of what a player is. This down here is a specific instance of that definition. It's an independent thing that has variables that are defined and the behaviors are defined the same way. But as the program goes on, these variables can differ from another instance, like player 2. Okay. So now we need to talk about self. Self is saying it's like an ID. It has to be in every initializer function for this to work properly. So that's another thing I forgot to mention earlier. You gotta put self at the beginning of your parameter list on your initializer function. This self is saying I am an instance of class player. I am a specific instance. So anytime you say self dot accessing something, you're getting that specific instance's variable. And so here we have health defined as this parameter. It's right here. That was passed in from right here or right here, depending on which instance we're talking about. Let's talk about player 1 for now. So health is 20. This is 20. So it says get my specific instance of health. It's already been defined up here, and that's okay. But it says get my specific instance of health instead of equal to 20, because that's what was passed in. Player 2 got 10. So player 2 says get my specific instance of health instead of equal to 10, because that's the value that I was given. And so this is setting the health, the speed, the armor rating, and the location of the specific instance to whatever was passed in. So if we wanted to spawn player 1 not at spawn, if we want to spawn them in somewhere else, let's say we want to spawn player 1 at a village. Let's say there's a village located at the coordinates 100 and the coordinate negative 200. And that's the X and Z coordinate. Yes, there's a Y coordinate up and down, but let's just ignore that for now. So their initial start location is not 0, 0. Their initial start location got passed in as 100, negative 200 for player 1. So when they first come into the game, not spawn, they're a few hundred blocks away. And that's what self is doing. It's getting a specific instance. So this get location, we actually need to pass in self. And we need to say self dot location. Because that's going to get the specific instance of whatever location that our player is at, our specific player. So when we call get location, we don't have to pass in something. That's the confusing part. Whenever you use self in your parameter list, it's like an invisible parameter. If I jump back up to here where I had my error, notice here it said init takes 4 positional arguments, but 5 were given. That was before I had this self in here. So we had health, speed, armor rating, location. Whenever I defined it down here, I put 20, 1, 0, and a list of coordinates as my 4 parameters. And it said, hey, you gave me 5 parameters. If we jump back, there's only 4. But it says I gave them 5. That's because in between us writing this code right here, when it ran, it actually inserts self as the first parameter without telling us. So it's confusing, yes, but it puts self there before it runs the initializer function. So that's why it said 5 were given. It says it takes 4, but 5 are given. And I was like, oh, it's because it sneaks that self in there, and it's expecting you to put self as your first parameter here in the list. And I didn't do that earlier. I didn't do that, and I had health, speed, armor rating, and location. Okay, so you have to put self as first parameter initializer function, and then you have to also pass it in as the first parameter for every single child function of that class. So I had to put it there as well, and here. Okay, and then I'll say self to armor rating. All right, and there is one more thing about classes. I know this is a big section. Classes are a really big thing to hit, but they're very important to understand, so bear with me. These variables here in this class, these are called attributes. You can also just call them class variables, but these are known as attributes. These here are also attributes, but these are called instance attributes. And it looks like I'm just referencing these here and these here as the same thing, but they're not the same thing. Let's imagine this. There's something about a player that is true for every player. And that's like the height of the player is 2 blocks. So every player is 2 blocks tall. So we'll say height is equal to 2 for 2 blocks. This is the same for every player, and this value never changes. Let's assume we're not talking about mods or anything else. This value never changes. Players are always 2 blocks tall. Every player is 2 blocks tall. So we define this class attribute here, and then we don't touch it after that. It's always 2. But down here, we've changed the health, the speed, the armor rating, the location. And so we don't actually have to define health here, nor do we have to define speed, nor do we have to define armor rating or location, because these are actually instance attributes. The health value of a player is an instance attribute. The speed is an instance attribute because it can change. The armor rating is an instance attribute. It can change independent of other players. And so is the location is an instance attribute because it also changes independent of other players. The height of a player never changes. And there's other things that never change too about players in Minecraft, but we won't go into that now. So when we say self.health equals health, when we create this player, we're saying this specific player's health is equal to this. Their speed is equal to this. Their arm rating is equal to this. And the location is equal to this specific value. And this might be different from other players. And the important thing to remember is that the reason we're doing it this way is because health can change independent of other players' health. So it could speed, armor, location. And so that's the difference between a class attribute. So I'll say here, call this attribute. I'm going to butcher the spelling because I always do. Here we're going to say instance attribute. And anytime you think of instance, just think specific player for the player class. If it was a chicken, it'd be a specific chicken. Anytime you see attribute, these are things that are common among all players and that never change. Common among all of whatever this class is and never changes. And that is the last little wrinkle of classes. We have this height here, which is the same for all of them, and it's not really tracked independently. And then we have our initializer function. This initializer function says when this class object is created, when this player is created, do this as it's created. And that is set its health equal to some value, its speed equal to a value, its armor rating equal to a value, and its location equal to a value. And these are all instance attributes because they apply specifically to that player instance. Instance being a specific player. And we're doing it this way because health is tracked separately between different players. So one player's health might be this, another player's health might be something different. Speed is similar. A player might have slowness, or it might have speed 1 or 2, or it might just be running at regular speed. Each player has a different speed. Armor rating is the same thing. They have separate armor ratings. And they also typically have separate locations. And so that's why we are using them as instance attributes, because they apply specifically to the instance of that player, not another player. I'm sorry if I'm just beating a dead horse here, but I'm trying to repeat myself as many times as possible, because this was something that I didn't get for quite a long time whenever I was first learning it. Okay, so after we've defined our initializer class, the next part of a class is all the behavior functions, everything that this object can do, everything that can be done to it. And typically that is to modify its attribute or its instance attributes. But typically the instance attributes are modified more than the attributes. So we define functions that can get the value out of there of whatever instance and report it to whoever needs it in our code, or it can set it. It can set the armor, like the armor rating here, can set armor rating to whatever it needs to be set to, depending on what the player has. Same thing for health, same thing for speed, same thing for many other metrics or many other data values associated with a player. And this is just for a player. Cows have their own attributes, sheep have their own class attributes, so do Endermen, so do zombies. Every other entity in the game has its own attributes. And it doesn't just end with entities in Minecraft, but also blocks. So we might define a class and call it blocks. And that's going to have different attributes as well. Like it might have an opaque value. It might set that equal to true at first. It might have a break time. And that, well, let's just say it's like, I don't know, 2 seconds. It might also have some other instance attribute that we need to define, like resistance to like explosions and stuff. And all these are instance attributes, like different block types will have different values. So we might put this in the initializer function instead. So we'll say define __ init self, and then we'll put in those attributes down here. say self.opaque, self.breaktime, self.resistance. We'll pass those in. These are real values that a block in Minecraft has. It has an opaque value, break time, and a resistance. Opaque, you may never heard opaque, but I think that's like if a redstone signal can pass through it and other things like that. Like I don't think glass can have redstone pass through it, but I might be wrong. But yeah, so you might have a block glass that's like that. You might say, I don't know, something that's true for all blocks in Minecraft is that they are, their dimensions are equal to 1 by 1 by 1, as in 1 meter by 1 meter by 1 meter. And you can say that's true for all of them. Anyway, I can keep going this example. I don't want to code the whole game of Minecraft here in Python. That would be ridiculous. A ridiculous amount of coding. But hopefully you see the examples and you see the point I'm making here about global access to variables, why classes are so important. Okay, so just to overview classes, recap on classes real quick. They're used to encapsulate data so that we can not have global access to everything in our code, and we make bugs that are really hard to track down or can be fatal or can be really troublesome. But we also do it functions. It's for code reuse, so that every time we create a player in a game, we don't have to keep writing new code for every new player. That would not scale whatsoever. We can just reuse the same code for a different player. And it allows us to block our code into smaller logical units. It allows us to, instead of writing one big, long, continuous program, it allows us to say, hey, I have a block of code here. It defines the behavior for this specific part of my program, for a player, or for whatever else. And once I have typed all that out, I've completed one logical unit of my program, one step of it, and I can move on to the next step, and I can forget about this for a little bit. They'll have to like keep track of what I'm writing in one long global script. That is the point of classes. That's why they're so important, and it's why it's included here in our introductory course. Okay, so that was a long video, probably the longest one so far, but thank you for watching it. There'll be some more videos coming up, and I hope to see you there.